again, darling students. Per usual, you should have this open. We are all the way down in type 6. We've made it so far. We're over halfway done now. And I hope you all enjoy my nice meme, and I hope you all understand it because you all remember the trig identities. Now I've given you a little hint here. You should read that on your own to help you tell the difference between all the previous ones. Okay? Let's get started. Type 6, using the fundamental identities. Notice that I very creatively made identities full of equal signs. That's because an identity is where equality is true for all values of x. There's not just one unique x. It's no matter what the x is, we have equality. Oh, sorry about that wiggle. All right, now in case you forgot, I did a little summary here that the fundamental identities are the reciprocal identities, secant, cosecant, cotangent, ratio, that's tangent is equal to sine over cosine, and cotangent is equal to cosine over sine. Pythagorean, that's when sine is squared and cosine squared. If you add them together, you get 1, and plus you've got the secant, tangent, cotangent, cosecant. And then even and odd, what if the x is negative? Now, if while I was reading that, you were like, I have no idea what she is talking about, then you should go back on Google Classroom and freshen up. Fundamental trig identities practice. Use the flashcards, do the Quizlet, practice up, okay? All right, so we are doing just one example from that list of, I think it's about 7. So hopefully after you see one, you'll know how to do the rest. So again, we ask ourselves, can you combine like terms so they have just one term with a trig expression? Well, if the answer is yes, then we would try to isolate the trig expression. But we can see here that we have 2 different terms with 2 different trig expressions. So it would be impossible to know which one we should isolate. So our answer is no. That means it looks like one of these 2 options. 2 terms with different trig expressions, check, that's what we have here. Or 2 terms with the same trig expression with different exponents. So we're dealing with the first case here. And last time we had only 2 steps for what to do. First is to get equal to 0, then check for GCF, and then we try to factor. So we have worked through the 3 different types. Now, if 2 and 3 don't work, then we move on to type 4, where we substitute one of the terms with an identity so that all of the terms have the same trig expression. Okay, so that's what we're going to do up here. Now we can skip on down to step 4, but just for consistency's sake, I'm going to work through it all. So first we're going to get it equal to 0. All right, so I'm going to pass this 2 sine squared to the other side. Since it's positive, I pass it subtracting. So I'm going to have 3 cosine of x plus 3 minus 2 sine squared of x is now equal to 0. Oh, and I forgot to put that for this, we do have the restrictions that x is between 0 and 2 pi. So we know that our answer needs to be in radians because I gave you the restrictions in radians. So sorry about this wobble that keeps on going. This table is not the best. So we've got it equal to 0. Now I'm going to check for GCF. They don't have anything in common. Well, I've got a 3 here and a 3 here, but this doesn't divide by 3. No trig expression in common, there's no GCF. Try to factor. We could only do that if we had the same trig expression, just raised to a different power. If this was cosine and this was cosine squared, then we could try to factor. So instead we're going to try using an identity. So remember, we have an identity that involves sine squared and cosine, so that we could change this sine squared to be involving cosine. It's going to be our Pythagorean identity, right? We have that, I'll do it in another color. Oh my god, I hope it doesn't fall. Sine squared x plus cosine squared x is equal to 1, right? Now I want to change sine squared to be involving cosine. So I'm going to solve for sine squared here. So I'm going to pass cosine squared subtracting. So sine squared x is equal to 1 minus cosine squared. So now I can replace this sine squared with 1 minus cosine squared. Maybe it'll look like, since it's wobbling so much, that like you're nodding along because you understand everything I'm saying so well. You're like, yeah, I get this. I can nod to this, if that makes sense. Okay, so I'm going to change the sine squared. So I still have 3 cosine of x plus 3 minus 2. Now be super careful here. Use your parentheses. So I've got 1 minus cosine squared x, and then is equal to 0. Let's do a little. Okay, don't forget your parentheses because I need to distribute this negative 2 to both of these terms. Okay, so I've got 3 cosine of x plus 3 minus 2 plus 2 cosine squared of x is equal to 0. Fantastic. Now, it looks like our second scenario, 2 terms with the same Trig expression but different exponents. So now I can try to factor. Remember, when factoring, we've got to get it into standard form first, right? It needs to look like ax squared plus bx plus c, squeeze, plus c. So I need to go from highest exponent to lowest exponent. This is my highest exponent, so I'm going to shift it up to go first. Then we've got the cosine by itself, so plus 3 cosine of x, and then 3 minus 2 is 1. And now I can factor, okay? So now I can factor. Remember, when my a is not 1, I need to find 2 numbers that multiply to be 2 times 1, so multiply to be 2, and add to be the middle coefficient, plus 3. Obviously, that's 2 times 1, because then 2 plus 1 gives us 3. We need to split up the middle piece. So we've got 2 cosine squared x. Hopefully all of this is easy breezy for you because you just finished 5 examples that were just like this. And then plus 1 is equal to 0. Group factor it, group the first 2, group the last 2, GCF, 2 cosine of x. We're left with cosine of x plus 1. Nothing factors out here, so I'm going to just take out a 1, cosine of x plus 1. Then I've got these 2 terms with a new GCF. They both have cosine x plus 1 in common, so I'm going to take it out. Cosine of x plus 1. And then I'm left with 2 cosine of x plus 1. Not sure if you did it right? Check. Cosine x times 2 cosine x is 2 cosine squared x. Cosine times 1 is cosine. 1 times 2 cosine is 2 cosine. 1 cosine plus 2 cosine is 3 cosine, and 1 times 1 is 1. So we know we've done everything correctly. Now, since I've got 2 factors that multiply to be 0, I can set each one individually equal to 0 and solve. So first I need to isolate my trig function. So cosine of x is equal to negative 1. Over here, cosine of x is equal to negative 1/2. And now it's what we've been doing for 6 types now. 6 times we've been doing this. Cosine is negative 1. Let's look on our unit circle. It's on our x-axis, so at pi, so x would have to be equal to pi. And only pi, because we have the restriction, so we don't need to add the 2 pi. Man, it's upside down or it's wobbling. I just can't make it perfect. And then over here we've got 1/2, so we look on our hand, cosine's to the right, so we got to put down this finger to have just 1 finger standing because that's our numerator. Here is pi over 3. So x is equal to some version of pi over 3, but we notice that it needs to be negative, and cosine is negative in these 2 quadrants. So we have pi over 3, 2 pi over 3, and 4 pi over 3. I'm hoping that by now you've got that down super fast. Now you have, I think, 6 more examples to do. Work through those, ask me questions as you get them, and good luck. Bravo. Good job, everybody.